Anglerfish. Very nice. Is that the topic of your paper? Anglerfish? That's beautiful. That's a beautiful mask. Did you make it? Either way, it's impressive. Yeah. Thanks for bringing it. Yeah. Hey, everybody. I want to introduce you just to take a few minutes here to Leon from the International Learning Hub, who's going to talk about opportunities for study abroad, which are ramping back up again. So take it away.
Good morning, guys. My name is Leon. I'm from the Global Learning Hub, so I'm a fourth year international relations major. And so, yeah, our main mission there is to make sure that like every UC Davis student has some sort of opportunity for like study abroad, whether that's like overseas, in the US, or even right here on campus. So for me, I was able to go to China. I was able to learn Mandarin. I went to Guangzhou. And then I was able to interact with Chinese students, and I learned a lot about their culture. And I was able to eat really good food, play basketball in my free time. So it's a really cool experience if you guys get the opportunity to do it. And yeah, with that study abroad, we have like over 200 programs available for all different majors. So yeah, other than that, we also have programs where like professors will go with you to that country. So it'll be in a really small class setting of around 20 to 30 people, and it's a really cool experience if you really get to know your professor in that small class setting. And then also we have programs where you can partner with over 100 different universities like over the world. So that would be like countries like if you went to London, you would be studying at the Imperial College of London. Or if you went to like somewhere in Asia, you'd be studying at some college over there, and then getting those credits like translated to UC Davis credits. And yeah, with that, we're located at the International Center. If you guys don't know where that's at, it's right next to Russell Intramural Sports Field. And we're open Monday through Friday, 9 p.m. to 4 p.m. So yeah, if you guys are interested, just raise your hands and I'll be passing out flyers after this. So thank you guys.
Thanks, Leon. Hey, what if you're broke? How much does it cost? How do you pay for it?
It kind of depends on the student, but yeah, there's if you receive financial aid right now, it applies to like your study abroad too. And there's also a lot of scholarships and grants available. There's one called the Gilman Scholarship, which is if you receive the I forgot what it's called. I think it's called the federal. I forgot what it's called, but if you receive that, you're eligible for that too. And UC Davis is like #2 in the nation for receiving that scholarship, so it's a good opportunity. And yeah, so just raise your hand if you guys are interested, and I'll pass these out. Thank you, guys.
Wow, cool. You should do it. Financial aid applies. Get out of the state, get out of the country, get out of the valley. It's a good thing. How about the Thule fog? Have you seen Thule fog? Has anyone seen Thule fog in years? Thule fog is this thick fog that would cause accidents on the 5, and just this thick thing that would descend for weeks at a time. We'd be socked in the winter, and it doesn't happen anymore because of warming. But we're in a cooling phase right now in the El Nino Southern Oscillation. We're entering this cooling phase, or La Nina, they call it. And so it's interesting, we're kind of reverting back to like cooler weather modalities that we haven't seen for a while. The rain is kind of, in a La Nina system, the rain is kind of it doesn't really predict the rainfall, although we've clearly had a bunch. We'll see if that was an anomaly or not. But certainly cooler temperatures. I think we're in for a very cool winter this year. Seen migratory songbirds screaming down south. The massive atmospheric river, which I've never seen before in October. So, Thule fog, like from the olden days, kind of cool to see. So, getting on task here. I got a bunch to fly through, so hang in here with me. I found an article that I'd really like you to read. It's up on, the link is up on the on Canvas. It's about basically spring run salmon, high elevation life history. Those fishes that go in the summer, that basically come up in the spring or summer and hold in the river before being able to access these high elevation rivers before the snow and the ice hit. And so this is basically, you don't have to read the paper itself. It's just an article from National Marine Fisheries Service. This was a project that Rachel Johnson, who's over at Center for Watershed Sciences, one of my coworkers, worked on. And it basically talks about this sort of an extension of this life history pattern that springers have, where certain juveniles will hold in the river, not just for a few months, but for over a year. And it turns out that's about 10% of the population. They hang in the upper river for over a year. But 60% of the returns in certain years are all these fish that have held through the river. And so what determines their success apparently is is ocean conditions. So in really crummy ocean conditions during the El Nino warming phase, we're in a cooling phase right now, but during El Ninos themselves, during the warm phase, we tend to have sort of a depauperate ocean system. We don't get those patterns of upwelling that bring a lot of productivity to the surface. There's not a lot of opportunities out there. So the fish that stay in the river and get big have a much better chance of surviving and being successful in returning back. And they figured this out using stable isotope analysis on otoliths and tagging the fish as well. And so it's very cool. It's a super quick read. It's been sort of processed for your reading pleasure on the NMFS, the NMFS website. The paper link is also there. So check it out. I think it'll describe better than I have this sort of life history diversity, these different options that are available for basically hedging salmon's bets. The other thing I'd like you to read, we're going down to Putah Creek tomorrow, so please check out The Brief History of Putah Creek by Peter Moyle, which is also attached. It's just a couple pages, gives you a little background. Submit the final paper tonight, prepare for Wednesday's midterm, and there's no other things due today. Putah Creek. So I really want to, again, encourage you all to join us at Putah Creek. People will be coming around 8 or 8:30, I think. We'll be there earlier preparing. We'll be using a whole bunch of different gear types that you'll be able to use yourselves and experience, you know, hands-on stuff. So when you go to apply for a job with CDFW, Fish and Wildlife Agency, you'll be able to say, yeah, I pulled the same, you know? It may have just been for a class, but it's experience and it's more than other people have. And so, and you'll get to see a lot of the fishes that we've talked about, a lot of native minnows, a lot of centruchids, which we haven't talked much about. And it's a lot of fun. So for the lab, it's required. For the lecture, it's not required, but it's extra credit. So if you sign in on the sign-in sheet, we'll give you a quiz worth of extra credit. That's 10 points, okay? Yeah. I sure can. How's that look? A little better? Okay, reasonably good. It's popping up. Yeah, it'll have to do, I think. So the way to get there, you can bike, you can drive. There's a place to park down here. But the way to get out here is to go, we're over here, right here. In get my pen going on here. We're right. So it is shown. So we're up here on in the lovely Grove. So if you go out Hutchison and cross the highway and go past Aggie Village, you turn left just past Aggie Village and you kind of zigzag down Garrod Road? And then you'll go past on the right, you'll see Ag Services, a bunch of tractors and welding equipment and stuff. On the left, you go past the sheep barn. And then you're like, where the hell am I? You just keep going. You zigzag past the sheep barn, and then you'll end up at the creek. You hang a right, and there's a place to park down there. So it's a little bit of a bike ride. I'm biking down there myself this afternoon, so it's not too much of a stretch. And we'll be there from about 8 till about 3 o'clock. Bring water, bring food, bring a hat and sunscreen. I don't know what the weather will do. Bring warm stuff, and then we'll provide the water gear. Waders and boots to go with the waders if you're seining, and life vests if you're on the boat and stuff like that. Yeah. No, you just got to sign in and hang out a bit. Okay. Yes. There's tons of parking, but try and find someone to go out with you. Just good best practices, right? Okay. So, last time we met, I was talking about different life history strategies to hedge the bets. And so we talked about fall run, late fall run, winter run, spring run. The fall run and late fall run tended to be fish that spawned in the main stem of the river, of the Sacramento or San Joaquin River down in the lowlands. The winter run and spring run devised a strategy to get as far as possible up the main stem before making a bolt for the highlands, where they would spawn in these really high elevation alpine rivers, which are largely unavailable. because of various obstructions. And as a result of, so the life history strategies historically created sort of an optimization of opportunities. And to some degree, this has left us with a Chinook salmon population that does remain in the valley, but it's very impaired because conditions have changed so much. So our fall run is pretty stable. The late fall run isn't recognized, but it will be shortly as a evolutionarily significant unit. The winter run is extremely endangered, and the spring run is well technically threatened, but it's actually quite endangered as well. And this is a cool picture that I just wanted to show you of springers. They're basically waiting here. They cruise up in the spring and they over summer in the river, and then they wait at these plunge pools until enough water starts coming down from the mountains to be able to make a dash for it up into the highlands. And so in the summertime, historically, you would come to these plunge pools up on the top ends of the main stem river, and you just see these fish just kind of circling, just waiting. And they'd be feeding on terrestrial insects and whatever fell into the water for the summer period. And the limitation now is that temperatures are so warm that there's just, the few rivers that are still available for them to do this in, temperatures are rising, making this less and less of a feasible life history strategy. Historically, springers were the dominant run. They constituted almost all the fish that were caught in the many, many canneries and canneries that were along the Sacramento-San Joaquin River. And they were mostly coming from the San Joaquin. What happened in the San Joaquin is that in the late 1800s, agriculture started developing the rivers and utilizing water such that the river was running dry by the time it hit the delta. And since the river was running dry, diverted for agriculture primarily, there was no way for these fish to be able to get up in there in the spring and summer. And so that's been the main loss for these fish. Now they've recently been trying to restore it and open it back up. But the further limitations, because that was this sort of initial blow, agricultural development, which was followed by dam development and water district development. And so it's definitely an uphill battle for these fish. There are a couple of streams where they're successfully able to spawn, but they're up on the Sacramento River now. So coming back to this, I just want you to check out the trends again. So I talked about winter run here. It's not cooperating with me today, sorry. Try it again. All right, it's working now. So the winter run, extreme decline. So the winter run, this is a trip, the winter run used to go all the way up into the Cascades into Oregon and possibly a corner of Idaho, but mostly Eastern Oregon and northeastern California. And all that access, that's up past the McCloud River that we talked about with trout, all that access has been cut off primarily by Shasta Dam, which is like the mother of all dams in California. It's a giant dam, and there's no opportunity for fish passage either up or back down. And so the only cold water pool that's available for these fishes is at the foot of the dam. The dam holds so much water that it's got a cold water pool down in the bottom. And so most years, that's the only spot that winter run are going to be able to spawn. This last year, there was no water. The dam held like 1 million acre feet, a fraction of what it normally holds. All the cold water was drained out very early in the year, and the warm water wasn't sufficiently cold to sustain the population. And so they all went into hatcheries where they were raised in chillers, basically, and then trucked down to the estuary for release in hopes that they come back. Spring run have a similar kind of sad fate that I just discussed. Fall run, you would say fall run are not looking bad. Fall run, it's kind of up and down, and they're not maybe in the best of straits compared to the 1970s, but in general, there's a little more variability and a little more, I guess it feels like you could have a little more optimism about the population. But when you dig into the numbers a little bit, it turns out that the wild spawning fall run is declining over that same period of time. You can see there's an overall trend that's a decline. Excuse me. And the percentage of hatchery, the percentage of hatchery fishes is increasing, such that today, almost all the wild spawners are genetically identical to the hatchery spawners. And that's bad news. Essentially, we're running on borrowed time here because hatchery fish tend to be genetically homogeneous. And I've talked about this a little bit. They essentially were selecting for a very narrow suite of conditions in the hatchery. And these fish are really plastic, right? The fact that they can adapt to these different lifestyles, these different life histories across a really varied landscape from here to Russia means that they're kind of plastic. And so hatchery fish have become kind of pet fish. They rely on the hatchery and they're not adapted for extreme conditions, which means that at some point we expect the fall run is going to collapse. When conditions go outside the norm and the hatcheries are no longer able to like accommodate that, we suspect that there's going to be a crash like in the next, predictions are hard in this business, but essentially that population is probably in much more peril than it seems on the surface. Yes. 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 So we're maintaining numbers, kind of. Numbers are steadily declining, even in the hatchery population too. So, and this graph kind of belies that. But overall, the population is declining, and the proportion of hatchery genetic fish that are derived from hatcheries is increasing. So we're increasingly relying on that. And so we think that their fitness is overall decreasing. They're less well adapted for future events. And that explains the overall kind of stochasticity and variability in the population of fall run after overall. So in other words, in California, salmon are pretty imperiled of all the different runs. And this is true of some of the Northwest runs as well. The Columbia River stocks are pretty imperiled. The Fraser River up in British Columbia has not been as productive in a number of years. The Alaska runs and northern British Columbia runs off the Yukon are probably much more productive, but they have a little bit of a buffer because they're so far north. A lot of this is, a lot of the insults to the landscape from human development are sort of being taken to a new extreme because of climate change. And these are the key drivers here of salmon declines. The first one, which I didn't put in here, is agricultural diversions, which date back in California to the 1800s. It's been going on for a very long time. Rivers drying up. Obviously, that's a huge impairment to be able to move upriver. Dams and other passage impairment like weirs or channelization of the channel that's straightening it and deepening it, which reduces habitat and increases flows, makes it very difficult for these fish to get upstream. So dams and passage impairment is really critical. They can't get to their spawning grounds. Logging and agriculture have been a big impact as well because it mobilizes sediment. So when sediment hits these streams, it basically fills up the pore space between gravels. And when the eggs get laid in the gravels, which are historically clean, there's just no oxygen to breathe. It basically fills up those spaces. And so the eggs get smothered by the sediment. Toxic chemicals. I gave you the example the other day of tires, chemicals from tires, which are actually directly poisoning silver or coho salmon moving up into waterways, both the spawners and the juveniles. Another sort of related to logging and to agriculture is the loss of riparian corridors. So riparian refers to stream side. Overhanging vegetation, like you see in this picture at the bottom of the dam, that overhanging vegetation had an important impact on cooling the stream. And when that gets lost, the streams get really hot, especially for like fish that go down river like silver salmon or coho salmon that go down and hold in lagoons and estuaries through the summer before that bar gets blown out by fall flows. They're really vulnerable because it's just so damn hot in the bottom of the estuary. And part of it is just sedimentation and also the lack of overgrowth of willows and other riparian trees. And then finally, that's related to temperature and climate change. It is just getting hotter. And it's really, we're the southern range of the salmon, and we're really feeling it in this state. And then hatcheries, rather than being a solution, it seemed like such a great idea. We'll block the passage, we'll keep the water, and we'll just raise the fish in hatcheries. The hatcheries are a poor strategy. It's ultimately not going to, it's short-term gains to keep the fishery going, yeah. Long-term gains, there's a lot of problems with hatcheries. So any questions about salmon? We're going to move on. Cool. I want to talk about Putah Creek and reconciliation ecology because we're going down there tomorrow. I'm super stoked. It's like the funnest day of the quarter. I hope to see you all there. This is the Putah Creek watershed. It reaches all the way up to the west of Davis. We're here. It reaches all the way up to the west, past Lake Berryessa, all the way over into Lake County, where it pokes up out of Cobb Mountain, which is just south of Clear Lake. And historically, the creek ran through what was Pope Valley and the town of Monticello, which are now at the bottom of Lake Berryessa. I've included these pictures here because they give you a vision of what Putah Creek might have looked like down here in the valley as well, historically. And the thing that's really notable is that from these pictures, you can see the creek. When you look off at the Davis landscape, you look off to the south, you're on the levee, you're maybe driving down 113 or just hiking down south by Putah Creek, really. And you look south and you don't see anything. You see a bunch of trees, a little green scar on the landscape, but the creek's way down low. Back before the creek was dramatically altered, it was even with the landscape. And so it was right up there on the surface. And it was kind of an unusual creek in the sense that it's not like the Feather River or the Yuba River or the American River, which are the east side tributaries going into the Sacramento River. Both Putah Creek and the northern creek, Cache Creek, which is up in northern Yolo County that comes out of Clear Lake. These rivers are a little bit unusual because they kind of petered out. Essentially, they went underground probably before they hit the Sacramento River, which is notable because historically they probably weren't salmon creeks. They might have been open for a short period of time to let some salmon in, but in general, these were discontinuous creeks that were perched up on the surface of the landscape, periodically open to the Sacramento River, and probably let in a sort of select subset of native fishes, particularly a lot of native minnows. And that point becomes really salient later on when I talk about novel ecosystems. So a little bit more about what happened to the creek in 1870s. Putah Creek was still flooding what was then called the town of Davisville. And so the South Fork of Putah Creek was created. And that's essentially the creek that we go to today. If you walk through the Arboretum, that's the old creek scar from Putah Creek. It used to run really close, right, essentially through the southwest corner of town. And that became problematic, so they started pushing back. And the river now, and then they dredged a new starter channel down where the creek is now, which the Army Corps of Engineers followed up in the 1940s by dredging deeply. And at that time, flows were unimpaired. And so what happened is that dredging and that diversion created this very deep channelized basin where flows were really fast. The energy wasn't dissipated by meanders, which tend to slow down a creek or a river. It barreled right through and it undercut the creek. And so now today, Putah Creek's 40 feet below the landscape. That's why you don't see it. And then to add insult to injury, they built the Monticello Dam and started filling up Lake Berryessa. And they built farther down the Solano Lake Diversion Dam. So this had a couple of effects. One is that we now have a giant lake up to the west of us, which is drinking water and ag water for Solano County and also available for recreation of a whole suite of species, including rainbow trout, which are stocked there, and kokanee, which are stocked there, and largemouth bass, which are stocked there. People go out in boats, play loud music, water ski, catch fish. Cold water now comes from the bottom of the dam. So what would have been sort of a warm water creek is now on the upper reaches just below the dam, is now a freezing cold, dangerous stretch of habitat that then goes down further and hits Lake Solano and the Putah Creek Diversion Dam, where it sits and warms up. 95% of that water then gets diverted down this canal down to Solano County, which owns Lake Berryessa, quote unquote. And the rest of it is warm water that trickles through this region of the creek that we know, our lower Putah Creek, which runs by us. And in this picture, I put this in here because you can see how it's just kind of a straight channel. It kind of zigs and it zags, but it doesn't do this, which is what you would see. And what's going down that creek after they dredged it and channelized it is just a little bit of water. And this became an enormous problem that people finally recognized the implications of this back in the 1970s, in the 76-77 drought, which is the first of the series of droughts that we've had since that decade. It was a very deep, short drought. Flows slowed down. And it was followed up by the 1987 to 92 drought, which was much more protracted and got people's attention. They found that the creek just wasn't running, literally wasn't running. And so portions of the creek here in Davis were either dried up or just filled up with stagnant water that was complemented by the old dead cars and washing machines and tires that had been dumped down on the creek for many, many decades. And why would you dump a car down by? Well, just a ditch. It's expensive to take it to the dump or to an auto recycler. So you just drive your car, tow your car to the ditch and just dump it in because nobody really cared. This is what it looked like in June of 1996. And so people in Winters and in Davis got kind of huffy about it, and they formed the Putah Creek Council. And the Putah Creek Council worked to clean up the junk on the creek. And they started petitioning Solano County saying, hey, listen, you're responsible for this. You're not letting any of the water that historically flowed through the creek. And now you've got this, you've got an eyesore, you've got a potential health hazard. And Solano County backed itself up against the wall and said, too bad, we own the water. And so the Putah Creek Council, Davis, and UC sued them. And this is back in 1996, and they won. There was a settlement in 2000. And now, very interestingly, Solano County Water Agency is like one of our partners. The administration of the agency has changed over time, and they're much more enthusiastic about doing the thing that really they had to do. And this is why they had to do it. There's a section in California Fish and Game Code called Section 5937. It's the one legal code you might want to memorize for this class and for your future. 5937 is landmark in that it says that the owner of any dam shall allow sufficient water at all times to pass over or through the dam to keep in good condition any fish that may be planted or exist below the dam. In other words, if you have a dam, you gotta release enough water so that the critters that live below it can live, and you still have a living river. And this is the first time that even though this was codified in Fish and Game Code dating back to at least the early part of the 20th century, it had been really neglected. And so this lawsuit dredged it up. Peter Moyle was one of the people who testified that fishes were not being maintained in good condition, and the judge agreed. And so the goals, essentially the settlement with Solano County has provided what we will see tomorrow down on the creek. They have to keep the creek from drying up. They have to provide spring flows that allow native fishes to spawn, spawning habitat for native fishes. They have to provide fall attraction flows for salmon. So even though it's not a salmon river, we said, well, there's an opportunity for salmon to get up here, and there might be even cold water opportunities. So now that it's connected perennially to the landscape, let's make sure that they can get up and use this novel habitat. And then high flows at certain periods during the wintertime to push out some of the non-native species, to sort of select for native species. And we found that we have a bit of control here because a lot of the non-native species are from the Southeast, catfishes, cincharchids, sunfishes. They all come from the Mississippi River Basin, and they're all used to warm, slow-moving water. And so, so the theory was that if you throw a bunch of water when you have it, it washes those fish out and selects for native fishes that are adapted to that sort of environment. And then also high flows to support channel processes, to move sediment, introduce meanders. Those meanders eventually would disperse some of the energy of the stream and allow it to function. Not like, when you have high flows, you don't want a column of water screaming through like from a fire hose. You want it to slow down enough to support habitat characteristics that are desirable. So, this work, this idea was based on this thing from Poff et al. Called the natural flow regime. And it hypothesized that if you introduce flows at certain times of the year, you could select for the kinds of fish that are in the river. And this is the first demonstration of that idea from theory. This is an opinion paper by Leroy Poff. Well, this is the first time that an opportunity occurred to actually test it, just back in really the 2000s. And so up here in the upper left-hand corner, this is an interesting thing. Hang in here with me for a second. During the pre-accord, you can see the pattern of flows, and you can see that every winter, this is across years, and this is, what is it, mean daily discharge. So you can see across the years, there's these spikes. Those are winter spikes, and they're interspersed with these really dry periods, which are the summers. And then there's periods like this, which are just always dry, which are during drought periods. Well, if you look after the accord, it's easy to look at that and go, I don't see any difference. It turns out that very little water was required to implement the accords. So on this kind of course charting here, you don't see a lot of differences from pre to post. The amount of water from Solano County was really negligible. And so the fight was over just a little bit of water. But it's not so much how much water, it's when the water goes on the landscape. And we think that this is really good news because it allows more, well, I'll get to this point, but just hang on to it until I kind of make the idea a little more clear. It's easier to pull stakeholders into the table to support conservation if they have to sacrifice a little less than they had to sacrifice. And so it feels a little bit like they're getting away with something, but at the same time, it provides opportunities for collaboration that didn't exist. And I have to say, Solano County today is a pretty decent collaborator. So this is what they did. And this is sort of like the flow regime that I just kind of walked through in the previous slide. So in a wet year, in September, we have these attraction flows. And then in midwinter, when there's a lot of water coming down, these are the high flows for channel development and flushing out non-native species. And then in the spring, we have, it relaxes, the flows relax. And then in the spring, another pulse to allow for good spawning conditions for native fishes that rely on that spring pulse. That's in a wet year. In a dry year, there's just going to be less water available. And so the agreement was that, well, you don't have to have as much water because in a natural condition, you wouldn't have it anyway. But if you maintain the same pattern, the creek will ultimately benefit and will select for native fishes. So again, we have the fall attraction flows, the spring flush, the winter flush to push out native species and build channel development. And then in the spring, spawning conditions for natives. And the question was, well, will it work? Well, the data suggests that it worked pretty damn well. Before the accords, we had a lot more aliens and very few natives. And that's kind of flipped in the past decade or two. We're seeing a lot more natives in the creek, which is actually very welcome news and shows how much can be done with so little in this particular river. So it's kind of exciting for the community in general. So the thing here, the lessons that we took from this is that functional flow regimes can work. And then prior to this, we had few salmon, which was kind of what we'd expect given the fact that it wasn't a salmon creek. But after the accords, 2013, we got 10 that came up, creating a lot of excitement in the community. It increased year after year. During the last drought, we got about more than 500 salmon. And in 2018, following the drought, it was a big wet year, 34,000 out-migrating juveniles in a trap that we have set on the creek, which is extraordinary. Now, how many of those are returning is up, we don't know. 2018 was 3 years ago. They should be coming back in this year. And so maybe we'll see some. We just had the traction flow, right? Last week, it was pouring. So we expect that, and I should clarify, not only was it raining, but Solano County was releasing a lot of water from the dam because this is the period of the attraction flows. So I'm hoping that maybe we'll see some salmon out there, depending on whatever happened oceanside. I just threw this in because it's actually not, it's one thing to say it, but it actually takes a lot of people to make it happen. So Peter Moyle's been involved, that's Moyle on the left. Rich Maravich is the Putah Creek streamkeeper, who's pretty active in leading the Putah Creek Council, local landowners, and scads of students who are just invested in what's going on in the creek, keeping it working, and it means a lot of collaboration and sometimes contention amongst the various stakeholders. But ultimately, it's been a pretty successful effort. They've done a lot of restoration. A lot of the trees that we'll see on Putah Creek just weren't there before. They were planted by the council and others, and it's become a pretty rich riparian corridor down in the gully where the creek exists. So that's the history of the creek, and we're doing science on it. So this is, I mentioned the trap, the screw trap. This is a screw trap. It's a giant slow-moving propeller that directs fish into a holding basin at the end. And that's how we sample the salmon juveniles as they come out. We also have people going out in canoes. They're doing red surveys. So I don't know if I think I've mentioned this. So a red, R-E-D-D, is the term for a salmon nest. And the females and the males generally go in and they use their tails and their bodies to swipe away sediment and small gravel from the rocks. And it leaves kind of a clear, sediment-free mound or depression of rocks that they lay their eggs into. The females lay the eggs, first pass. The male's right behind them and release the sperm. And that's where the eggs will develop. And they do that to make sure that it's clean so that the eggs will be properly aerated and won't get bacterial infections and die. And so you can see these kinds of cleared out spots. And so they do red surveys to see how many fish. They also do carcass surveys to see how many reds were made and also how many carcasses they can find on the creek, which is an indication of spawner returns. I think I said this before, maybe I told this to just one of you, but salmon fisheries are like the easiest fishery of all of them to manage because you can always count how many adults come through. You can always find a way to count them as they move up the river. Most fisheries don't have that opportunity. So, and also the field trip, the Putah Creek field trip also collects data. We have, I think, 20 years of data from this fall field trip, and that's used in management of Putah Creek as well. And so these are your earlier cohorts of students who went down the creek to help us out, and this is what you'll see some of this tomorrow. There's a little weird fetishism going around with kissing fish. There's gonna be a little peer pressure, I think. I'm personally am not into that, but you'll be talking to TJ and some others who'll be like, kiss it. I don't know what I think about that. I feel like I'm violating the fish. You know, I feel sorry for the fish, so I don't kiss it. And then put this in because non-native fishes are still abundant. They're still there. They're not going away. And they're not going away because Putah Creek is something that never was before. Putah Creek is a novel ecosystem. Novel meaning brand new, different, unlike the past, and unlike what we expected for the future. And we call it that because it's really irreversibly altered. The fact that it essentially exists underground in a deep channel is not something that's going to be reversible for many, many decades. Certainly not with a major dam upstream. The dam might release some sediments, but even that would be unlikely to reverse the channelization that has occurred so intensively. So we have a morphology, a structure of the creek that's fundamentally different and not really susceptible to reversal. Have to check our time. Yeah, we're good. So we have a mix of native and non-native species. Sometimes they compete, oftentimes they coexist. So we have this novel assembly that really are driven by physical processes as much as they are interspecific competition. I'd say at this point in ecological history, the species that did compete, like the sunfishes and the Sacramento perch, they've already sort of, the execution of the competition has happened, and sac perch are no longer found wild anywhere in California. They live in ponds where they're isolated from those introduced species, which have sort of taken over because of they're more aggressive. So we have this mix now of natives and non-natives, and a few species have been extirpated that were natives. And humans are really part of this ecosystem. I put up the slide of Rich Maravich and Peter Moyle and the Putah Creek Council and the students and the volunteers. And really, to keep something like this going, it requires a lot of human effort and a lot of human decision-making regarding desirable outcomes. And what are desirable outcomes? Well, there's differences about what those might be. There might be desirable outcomes for ranchers working along the creek. There might be desirable outcomes for people who recreate on the creek and want flows for canoeing. And there might be desirable outcomes for fish freak like me who have different ideas. But the whole thing of the council and this communication is that as a collective, we try to come to some kind of idea, some kind of concurrence about how we can manage this sort of artificial environment with habitat attributes that refer to historic time, but aren't exactly historic, that bring ecosystem benefits, but aren't necessarily traditional ecosystem benefits. And so we're kind of in a new era. And this unsettles people, of course, when you talk about it. But the reality is that many of the restoration sorts of opportunities that we would have liked to have seen a couple of decades ago, really that ship sailed. And so we're dealing with what's left. It turns out that what's left still has a lot of potential. It's not a depressing story, I don't think. I think some people find it depressing. I no longer find it depressing because it opens up a new suite of opportunities. Another example of this, just a slight diversion here, is the Marin Headlands and the San Francisco Presidio. They're part of the Golden Gate National Recreation Area. And out there you can see these beautiful landscaped slopes going down to the ocean, full of native species, native plant species. And it's like a garden. It's really been intensively planted. It's beautiful. Right next to it, you can see these patches of ice plant, which is an introduced plant, which is what used to cover those slopes, and it pushed out everything else. Left alone, those beautiful garden-like slopes full of all kinds of lupin and coyote bush and blue-eyed grass and all this like rich diversity would disappear under a carpet of ice plant, this succulent plant that's really well adapted to those environments. But humans are really involved. There are people who volunteer in the nursery. High school kids go out there, college kids go out there, and they work in the nurseries. They plant the plants. There's like the Ravenswood manzanita, the last and only remaining member of its subspecies, exists at an undisclosed spot in the Presidio. And they cautiously guard it and cultivate it and clone it. It wouldn't exist except for all the efforts of these people because it's a novel landscape. It ain't what it was. It's bordered by eucalyptus forest in a very densely populated town. So these are examples of novel ecosystems. And the idea derives from this paper that came out in 2009, which I refer to a lot, by Hobbes. And it discusses the idea, the concept of novel ecosystems, and we've gone a bit beyond this as our inspiration. And I just want to, refer to the map here. So the map is basically a human footprint index, and you can see, particularly in the subtropics, in the temperate zone in the northern hemisphere, there's a really intense human footprint. And then in some parts of the tropics, you can see that as well. The population has grown, but not only population, it's also resource consumption, which includes logging and water extraction, et cetera. And the concept behind this is that historical systems can be altered a little bit. Let me see how I can best make this point. So there's a progression from historical systems to hybrid systems that are slightly altered, but not completely, to novel ecosystems. And the theory with novel ecosystems is that restoration becomes difficult or impossible. And what are the conditions that make it impossible? Well, Hobbes hypothesized that there's two factors, and this is a really important point here. There's biotic issues and there's abiotic conditions. And typically what happens is that as we move farther along the abiotic axis, we move to a slightly altered state that there may be the potential in that hybrid state of restoring back to earlier conditions. Except that once you get there, you tend to also get an increase in introduced species that make restoration impossible. Once you get the introduced species in there, they can alter the physical habitat, the community interactions so intensively that it's really hard to go back from that point. Once you get an invasive in the system, it's super hard to eradicate it. You might remember the pike, northern pike were introduced to Lake Davis, and they tried to eradicate them using rotenone, and the first time they failed. And the second time they did a massive effort and a lot of community participation, and they managed to eradicate them. It's a rare success story on pulling out a non-native species. And that was a very confined habitat, whereas this is a very open habitat. So the example that Hobbes used was in Australian eucalyptus forests. And because of agriculture, the water table was dropping and becoming salinated. And so we saw this progression from less overhanging canopies to a sort of drier landscape. And at the same time, these trees, the biotic changes occurred where these trees started dying out and were replaced by these shrubby sorts of bushes. And those bushes outcompeted trees. So when they tried to restore water to the ecosystem, they couldn't get trees to establish because the shrubs and stuff that were there just wouldn't allow it to happen. They successfully outcompeted the trees that they were trying to replant. And so we have a novel landscape. Tends to be saltier soils, tends to be this sort of hybrid landscape of a few natives and mostly introduced plants. And there are no options for reversing that process. And so we call that a novel ecosystem. And the next question is, well, how can we manage it to make it more useful so it's not just a dead zone? And this sort of leads into the notion of reconciliation ecology by Rosenzweig. This is Michael Rosenzweig's idea down from University of Arizona. And so he calls reconciliation ecology the science of inventing, establishing, and maintaining new habitats that conserve species diversity in places where us humans live. And here are the key ideas. We want to integrate under reconciliation ecology, integrate desirable biota, animals and plants into human landscapes, work with these novel ecosystems and focus on natural processes using infrastructure and technology and a lot of human effort so that humans are involved in the landscape. Putah Creek's an example of this. Yellow Bypass on the way to Sacramento is another example of this. And we'll probably Jacob talked about floodplains a bit. We'll probably talk a little bit more about it later. You don't have to do participation questions. That's my spiel on reconciliation ecology. I got a few minutes, and so I want to talk about Putah Creek again. We're going to be sampling fishes down there. We're not going to be doing population estimates. We're going to be doing sampling. Sampling is looking at a subsample of the population and scaling it by effort. So effort could be the volume of water seined. It could be the number of seconds or minutes or hours that you electroshocked. We have a variety of methods we're going to use. There's active versus passive. Active is where we're moving nets and gear. There's a lot of different types of active gears. We'll probably come back to this idea, but I want to highlight some that we'll be using at Putah Creek. There's the beach seine, which is where a couple of you, maybe 4 of you, will grab the bailer, the brails on either side of a net and drag it through the water up to the shore. And then there'll be somebody there with a bucket where you dump the fish into and count them. It's really a lot of fun. You get to get wet. We'll have waiters for you. Electrofishing, which might be shocking to some of you. It's called, I'm sorry, I just came out. I was not, sorry, I apologize. That was an accident. So electrofishing, you basically run a current through the water. And we have an electrofishing boat that you'll be able to get on down there. And we'll also have backpack electrofishing. And here's I just really wanted to introduce you to this idea. And I'll let you go in a couple minutes here. Because it's a little weird. People get a little upset about it. We don't backpack electrofish to like shock them and knock them out. We run a slight current through the water. And because fish are long and skinny, the current affects different sides of their body differentially. And so for those of you who have touched an electric fence, we had that discussion already. Remember how your muscles started contracting? It's an involuntary contraction because it's an electrical signal, right? So on the side that's far from the electrical field, the fish are going to have less of a contraction. And on the side that's closer to the electrical field, they'll have a strong contraction, which means they turn and swim directly into the net. It's the weirdest thing in the world. You put your net in the water and you push the button and the fish go, and they jump into your net. It's kind of like, I don't know, it's like a cartoon. And then you pull them out and then you can measure them and count them. That's the guys following in the buckets right there. We'll be doing that on the creek. It's actually very exciting. It doesn't hurt the fish. We're very careful in our techniques. And like I say, We'll be using some other stuff too, including trapping. This is a clover trap. We're setting some this afternoon. I don't know if we'll have some fike nets, but we'll be retrieving them. And you'll be part of it. So thanks, everyone. Looking forward to seeing you tomorrow. Have a good weekend.